Good afternoon. Uh, Again, it is a drive to optimize the auxiliary power consumption. This project we have taken from the project period. The system of the compressed air, it has been normally a thermal power plant, coal-fired thermal power plant has the three types of compressed air. One is for the instrument, another is for the ash plant requirement to conveying the fly gases from the ESP collected hoppers, and the service air that has been used for cleaning and any other purposes. So in our plant, the entire system was fed through two types of compressors. One is for ash plant compressors, those are the rotary compressors, and for the main plant, it was the centrifugal compressors of Ingersoll Rand Bank. So our project was to upgradation of the compressed air system. We have tried to divide the compressed air system because the consumption in instrument air system is less. The consumption of the service air for ash evacuation or AHP requirement is more, and for the instrument air the pressure requirement is more, and for the service air the pressure requirement is less. So if we generate compressed air through an instrument air system, that means we are consuming much more power for a high pressure compressed air generation, and then we throttle down to a required service air pressure, almost 1.6 to 2 kg reduction in pressure, and then using it. That means we have make a great loss for that throttling. The existing compressed air system, these are the installed capacity, and these are the power supply sources from the unit bus and station bus both. These are the IR rotary, all these 6 compressors are screw type compressors, and those are taken power from the station bus. You can see that the total capacity here for instrument and service air combined, it is 54,119 cubic meter per hour. The pressure is 7 bar. Here it is 5,009 cubic meter per hour, but the pressure requirement is much less, 4.5 to 5 bar. So if we supply air from this system to this system, there is a huge loss for the throttling of around 2 to 2.5 kg. Now this is the unit wise consumptions. Unit 1, the PD pumps, it has been consumed near about 2565. The consumption in ESP is 2200. In the air preheater ash evacuation system, it consumes near about 800. Total 5565. And for unit 5, there is no PD pump. And unit 5 APH also don't have the air evacuation system. So apart from this consumption, the rest of the installed capacity is used for the service air, instrument airs, and there are many leakages, air leakages, which is very common for the all other units. So this is our compressed air system, the consumption details in a graphical form. These are the flow, and you can see the difference between the instrument air flow and service air. This is the specific power consumption. These are the actual delivered capacity against the installed capacity, and this is the required power, and this is the actual power. So this is the normal demand period. So the total demand is around, actual demand is around 40,800 cubic meter per hour, and the specific power, that means kilowatt per cubic meter per hour, is almost 0.102. And when the demand is in peak, it is the actual requirement is around 46,000, and the specific power, it is a little bit less, from 1.102 to 0.1. What is the existing compressed air system? The total instrument air and service air requirement is around 14,000 cubic meter per hour against 54,000 cubic meters per hour high pressure header. This is basically the the centrifugal compressors are generated. The conveying air requirement, the conveying air requirement is 24,000 cubic meter per hour. It is almost 10,000 cubic meter more than the instrument air requirement, but the pressure is almost 2 to 2.5 kg less than the instrument air pressure generated. Currently, out of 8 number of instrument compressors, 7 numbers are on unit bus, only 1 is on the station bus. So compressed air instrument air system is not an independent system, and tripping of units may hamper the compressed air system also. Out of these 8 compressor are designed for high pressure of 8.5 kg, presently running at the set point of 7.2 kg, leading to the higher specific power. This is almost 0.1. So air pressure of 7.2 kg per cm square is throttled to 4 kg per cm square, or 4.5, whatever you can say, and then used for as conveying transmitter or the conveying air or the air consumption in ash handling plant, was a huge throttle loss, as most of the consumption was in ash conveying system only. I have previously said that the instrument air consumption is much less than the AHP consumptions. So there is a huge loss in the auxiliary power consumption also. So the present consumption pattern is this. Now what we have done, the proposed solutions. The solutions are the compressor 1A and 1B. These are the oldest compressor, centrifugal compressor we have in our unit 1. The capacity is 5715. That means total 11,500 approximately. This has been refurbished and renovated and shifted for the conveying air compressor. The old 6 screw compressors, that was almost outdated. The spares you cannot get from the OEM also, and we have forcefully closed the operations of all 6 compressors, and existing air compressor 1, 2, 3, 4 and Khosla compressors. These are the screw compressors. It has been operation, or it has been closed, and we have installed 2 new centrifugal compressors of around 14,426 megawatt combined capacity. So the total capacity of the service air is almost 26,000 cubic meter. What is actual requirement is almost 24,000 cubic meter. So we have a 2,000 cubic meter margin also. So we have replaced compressor 1A and 1B, its air end through a low pressure moderate capacity air end from the old, and installed some what I can say, the surge tanks or air receivers to cater the difference in the compressed air consumption when the conveying system is in service for the dense power systems. This is the improvement projects, the 2 new compressors we have installed, and the compressor 1 and 1B, the air end has been replaced through a low pressure moderate capacity air end. The savings for this closing of the operation of all 6 old screw compressors and put the new two centrifugal compressors of Ingersoll Rand and Atlas Copco make. It gives us a 17.42 lakhs per annum, and replacement of the or refurbishment of compressor 1 and 1B with the new air in, it gives us a 26.42 lakhs per annum. This is the savings in terms of rupees. The actual total investment is 1.75 crore for one new compressor. The improvement in specific power from 0.095 to 0.085 brake kilowatt per cubic meter per hour. The APC reduction is almost 72 kilowatt per compressor. Drive towards sustainability of 0.6 million units energy saving per annum. The CO2 emission reduction more than 560 tons per annum is a green achievement. Ash conveying circuit is separated from instrument air, increasing reliability of instrument air and associated system. Instrument air system is crucial for operation of a power plant, the thermal power plant. The net saving is 17.3 lakhs per annum. And the retrofitting or modification, that means replacement of the air end of the compressor 1A and 1B, it gives us the total investment of 1.75 crore for two compressors. The improvement in specific power from 1.101 to 0.084 brake kilowatt per cubic meter per hour. The reduction is 208 kilowatt. The renewal of the obsolete control panel. We have replaced the obsolete control panel with new one. The ash conveying circuit is separated from instrument air, increasing reliability, and the saving is 52.84 lakhs per annum. So almost if we combine those, it is around 80 lakhs per annum savings in terms of rupees. This is the APC. There is some calculations, and this is the graphical representation of the how throttle loss can be calculated. And we also, for the improvement initiatives, we have introduced some of these water trap, moisture trap, so that when the condensed water is drained from the air receiver, it will only drain the water, but not the air. This is the water only, not the air. So here we also save some loss of compressed air. Thank you.
Any question, please?
Last presentation, Jojobera had one more chance, but they said no.
Sir, we have many more, sir.
They have many more, but anyway, they have said no. We have accepted it. So we will get more time to listen from Mr. Kulkarni, who is already there. Yeah. Any question? If no question, then let us take a tea break. Networking tea break. All right? Okay.
Thank you very much for your patience here.